I would like to discuss about wave optics. Wave optics by interference, diffraction, polarization. Some of the contents of interference, principles of superposition, interference of light, conditions for sustained interference, interference in thin film by reflection, Newton rings, determination of wavelength, engineering applications of interference. Optics. The study of behavior of light is subject of optics. Light is a form of energy that produces the sensation of vision. Light itself is invisible. When it falls on an object, the scattered light enters the eye and object becomes visible. Here, the sunlight is dispersion of the light from one place to another place, and the home light is the light is dispersion of the certain area only. The lasers one is the light amplification of stimulated emission of radiation. A dispersed eye, it is a monodirection and high directionality and high coherence and high intensity. So optics is the properties classified into three categories: geometrical optics, physical optics, quantum optics. Geometrical optics, reflection, refraction, dispersion. And physical optics is interference, diffraction, and polarization. And quantum optics by laser and non-linear optics. So, geometrical optics is reflection and refraction. So, what is the reflection? The reflection is the process of sending back the light ray which falls on the surface of an object. Here, the incident light falls on the object and reflecting back to the same light, sending back the light ray which falls on the surface of the object. Here theta I angle, incident angle, and reflection is theta R. And second one is refraction, is the bending of the light when it passes from one medium to another medium. For example, this is called incident ray, is the air medium, and it is called another medium, refracted ray is called glass medium or water medium. When the light rays travel from denser medium to rarer medium. Nature of light. Light is a form of energy, and energy can be transported in space in two ways. Number one is particle or actual motion of the particle, matter, wave motion. The intensity of light from a small source follows an inverse square law. Here, the particle tends to move from one place to another place. The moving velocity is v. The product of mass and velocity is called the momentum, and kinetic energy is of m squared. So the wave is spreading from the one place to another place. It is a crust and trough continuously. The wave, it is not the located region. It's spreading from the space regions. So what is the major difference between particle and wave? Particle and wave. So particle has definite mass and it is located at some definite point. It can move from one place to another place and it gives energy when slowed down. Here, particle is specified by mass, velocity, momentum, and energy. But wave is spread out over a relatively large region of the space, and it cannot be said to be a particular location. It's spreading from towards the one place to another place. It is spread out by frequency, wavelength, phase, amplitude, and intensity. But here, both the distance between wave and particle is like The particle is a mass of the particle. It turns from one place to another place. The moving velocity is v. Here the momentum is the product of mass and velocity, and kinetic energy is half mv square. But the wave is it is spreading from towards the one place to another place. Like it is called crust and trough, fixed wavelength, frequency, and amplitude A, and intensity or brightness. This is called the difference between wave and particle. According to Huygens wave theory, light propagates in the form of mechanical waves through either the medium, and this theory successfully explained the interference and diffraction phenomena. So Huygens theory, every point of the source is a source of a secondary wavelength. That is called Huygens theory. So wave is a periodic disturbance in a medium which propagates with time from one place to another place. We know that the wave spread in the form of crust and trough. So ripple on the water, the waves are produces like in a crust and trough waves in continuously. So this is called the displacement versus distance graph as shown in the figure. Any two successive crusts, that is called the wavelength, or any two successive trough distance is called wavelength. So what is the transverse waves? If the particle of the medium oscillates perpendicular to the wave propagation, that waves are the transverse waves. The transverse waves, it moves from the perpendicular to the wave propagation. And example is ripples produced on water surface. So the diagram is as shown in the figure, ripples produced on water surface and waves produced on rope. Another one is longitudinal waves. If the particle of the medium oscillates parallel to the wave propagation, that waves are the longitudinal waves. The longitudinal waves, it is a parallel to the wave propagation. Parallel to the wave propagation. It's spreading of the parallel wave propagation, longitudinal waves. And longitudinal waves, best example is sound waves in air. The waves produced in long horizontal spring. So longitudinal waves vibrate parallel to the direction of travel or the travel and the wave. The sound waves are the longitudinal waves. The major difference between transverse waves and longitudinal waves and transverse waves is the medium oscillates perpendicular to the wave propagation, that is called transverse waves, and longitudinal waves is the particles of the medium oscillates parallel to the wave propagation. So from the diagram is the rope, the waves produced on rope, and it produces the parallel spring, that is waves produced in long horizontal spring. What is the wavelength? What is the amplitude? What is the phase? The first one is wavelength, the distance between any two successive crust to crust or trough to trough distance. From the diagram, so this is called the crust. This is called crust. In between the distance is called the maximum distance between two successive crust or two successive trough. The distance is called the wavelength. Amplitude is the maximum. This is called the maximum displacement of the vibrating particle from its mean position is called amplitude. And phase is if the waves maintain constant or zero phase difference, that waves are said to be phase. If the waves maintain phase difference phi out of the 180 degrees, it is not a phase. What is the principle of superposition? My dear students, it is very important for in our examination point of view. Y1 and Y2, two displacements For example, this is called, here the two displacements. The first one is one wave, second one is another wave. So y1 and y2, this is called y1, and this is called y2. The resultant displacement is equal to the algebraic sum of two individual waves, y1 plus or minus y2. That is called superposition principle. When two or more waves travel simultaneously in a medium, the resultant displacement at any point is due to the algebraic sum of the displacements due to the individual waves. Y is equal to y1 plus or minus y2 plus or minus y3 and so on. If the positive sign has to be taken, both the displacements y1 and y2 are the same direction. The negative sign has to be taken, they are the opposite direction. When two stones are dropped at different positions in still water, or expanding ripples pass through each other without any mutual effect. That is called superposition principle. Based on the propagation and direction, the superposition of the interference is two types. One is a constructive interference, another is a destructive interference. In constructive interferences, the resultant displacement is equal to y1 plus y2 is a constructive interference. Y is equal to y1 minus y2 is called descriptive interference. The first one is y is equal to y1 plus y2. It is the same direction, and opposite direction is called the descriptive interference. What is the interference? When two or more light rays travel in the same direction. The coherent light rays is same frequency, constant phase difference, coincide in the space and time, then there is a modification of the intensity. The modification of the intensity due to the superposition of the two or more waves of the light rays is known as the interference. The resultant intensity at a point depends on the amplitude and phase relation of the waves. So in the diagram, it is a parallel wavelets. It passes to the S1, S2 slits. S1, S2 slits. These slits producing bright and dark pattern. So dark pattern is called descriptive interference. The bright pattern is called constructive interference. So here the constructive interference is, it passes to the light rays from equal and opposite phases is called descriptive interference, and equal direction is called same direction is called constructive interference. The constructive interference is, if the resultant intensity is greater than separate intensities, that interference is called constructive interference. And descriptive interference is, if the resultant intensity is 0 or less than the intensities of individual waves, then that waves of the interference is descriptive interference. What is the coherence? If the waves maintain constant or zero phase difference are said to be the coherence. Coherence is same phase, same frequency, same amplitude, and same wavelength. If the waves maintain constant phase difference pi, then that waves are said to be incoherent waves. To observe the interference, two light waves should be coherent. So coherence is the two types: temporal coherence and spatial coherence. And temporal coherence is the two light rays should maintaining constant phase at any time. That is called temporal coherence. And spatial coherence is the two light rays should maintaining constant phase, constant frequency at any point. That is called spatial coherence. So the maximum intensity condition is, if the delta phase difference delta is equal to 0, 2 pi, 4 pi, and 6 pi, etc. That means it is a 2n pi, where n is equal to 1 substitute 2 pi, n is equal to 2 substitute 4 pi, n is equal to 3 substitute 6 pi, and so on the values. Path difference is delta is equal to n lambda, n is equal to 0, path difference is 0, n is equal to 1 lambda, and simultaneously. The minimum intensity condition, the phase difference is delta is equal to pi, 3 pi, 5 pi. That means 2n plus 1 into pi. And path difference is lambda by 2. That is delta is equal to 2n plus 1 lambda by 2. So condition 2, observe the sustained in the interference. The two light sources emitting light waves should be coherent. The two sources must emit continuous light waves of the same wavelength and the same frequency. The separation between the two sources should be small. The distance between the two sources and the screen should be large. The amplitude of the light waves should be equal. The sources should be narrow. The sources should be monochromatic light. The sources should be monochromatic light. It is a single beam of light. It passes to the one place to another place. The amplitude of light waves should be equal. That means the wave propagation of the light from one place to another place. The amplitude needed to equal and equal. The waves must travel in the same direction. So the difference between a division of wavefront and division of amplitude. The division of wavefront best example is Young's double-slit interferometer, Lloyd's mirror, laser, and Fresnel prism. And division of amplitude is a thin film by reflection, Newton rings. The division of wavefront. In this method, the wavefront originating from a common source is divided into two parts by using mirrors, prism, or lenses, and two wavefronts the separate travel and finally brought together to produce interference. And division of amplitude is, in this method, the amplitude of the light rays of the beam is divided into two or more parts, either the one partially reflection and refraction. Thus we have the coherent beams produced by division of amplitude. These beams travel different paths and finally brought together to produce interference. So the diagram is as shown in the figure. So the way of division of wavefront, the sources is source of the light is dispersed from the crust and trough waves. Meet a point of S1, S2 slits. It is called the dotted lines is called the trough line, and continuous lines is called the crust line. So crust and crust meet a point is called brightness. Crust and trough meet a point is called darkness. That is called bright and dark patterns are produced on a screen. Here, a thin film by reflection, a monochromatic light falls on a thin glass plate, and it is reflection of return back to the light. These reflected light get superimposed with each other is forming interference pattern of maxima and minima interference. Interference due to thin film. It is based on the division of amplitude. Different colors are observed when sunlight falls on a soap bubble and thin film of oil on water surface. Then different colors were observed. This is due to the interference. Similar colors phenomena is also exhibited by thin glass plate and mica sheet. My dear students, so the interference best example is multiple colors of soap bubble. Multiple colors of soap bubble, floating oil film in view of under sun radiation. So the multiple colors of soap bubble, it is called in a visual colors or rainbow colors. Interference in thin film is due to the either reflection or refraction of light rays from upper and lower surface of the thin film. Yes, my dear students, thank you. Thank you very much.